All right, so today we are going to be learning about deployment. We're going to get our full stack React Django applications on the internet onto Amazon EC2. So this is basically just a simple Linux server that we're going to log into and install our application and then run it there in a pretty similar way to how we run it locally, with a few differences. However, there are a few differences between how the app runs locally and how it's going to run in production that I want to talk about here before we dive into things. So I guess the first problem that we have to deal with is that the built-in server in Django is not fit for production. So, when you're just typing python manage.py run server, this is like a handy development server just for testing, developing, debugging your application locally, but you're not supposed to expose this web server to the public internet. It's not like robust and strong enough to handle multiple simultaneous requests. It's not fast enough to handle all your static file needs. It's just for testing locally. So, let's see here. So can't use built-in run server. So the way we're going to do this is we're going to actually use another web server called Nginx. So I know this is spelled really strangely. It's pronounced Nginx. This is a generic open source web server. I guess we can check out their website real quick. So this is definitely like a really popular piece of technology, very successful, been like maintained for a long time. A lot of people depend on it. So this is definitely something that you'll hear about in the future, especially in relation to other languages, other server frameworks. A lot of people use Nginx for deploying their applications. So we're going to have to install that on our server, because this is actually good for listening to the public internet. It's going to be robust and strong in the face of, tons of people sending us requests at the same time, trying to access our static files. However, this creates another problem, which is that Nginx doesn't intuitively know how to work with a Python application. So it's not obvious how we get Nginx to communicate with Django. So unfortunately, we're going to actually add another web server into this mix. So after Nginx is receiving requests from the internet, Nginx is going to pass these requests off to another web server called gunicorn, which is another kind of weird name, I'm sorry. Okay, so gunicorn, another tool that we're going to be using today. This is their website, another pretty popular server tool, but this is more Python specific. You know, it works for WSGI applications, which I know we never really explained what this means, but we did mention that Django is a WSGI application. You do have that WSGI file in all your Django apps. So we're going to actually be using that today. All right, and so then gunicorn is actually able to pass the request from Nginx to Django. But not only does it just pass the requests, one at a time, but gunicorn is able to run multiple copies of your Django application simultaneously, so that way multiple users can use your application at the same time. Because normally Python is not asynchronous and it's single-threaded. So by default, there isn't an obvious way that you can handle multiple connections at the same time. So gunicorn actually, depending on how many CPU cores you have, can run multiple copies of the application simultaneously to handle greater amounts of traffic. Okay, so those are the big new technologies that we're going to use in order to solve these problems that are going to arise. I want to talk about also just generally what we're going to be doing later today. So I did mention that we are deploying our application onto AWS EC2. So after deployment, we're going to set up some DNS settings. So I've purchased a domain name, and so I'm going to associate the domain name with the server that I'm setting up in Amazon, so that we don't have to just type in an IP address to access our application, but we can actually type in a URL.
Quick question, Raphael. Is there a different, like a default URL if you don't purchase your own URL for EC2?
There is a default URL that they'll give you. It's something like, Amazon AWS compute.com / your user ID number / the instance ID number. So there are two ways to access it by default. So there's that URL, and then there's also the IP address. But we're going to try to be a little bit more professional about this. So I've actually purchased a domain name so we can look like a real website.
Okay, cool. Yeah, thank you.
Yep.
Yeah, I was just wondering if we can also host stuff for free. So thanks.
You can. Oh, and please, people, ask many questions. Don't be shy about interrupting. I know a lot of the stuff is going to be new for a lot of us. So please, if anything seems unclear, you're not sure why I'm taking an approach to some particular problem, feel free to just shout out your questions. All right. So later we're setting up some DNS. And then the last thing we need to do is we're going to set up HTTPS. So after we have a domain name for our web application, we're going to get an SSL certificate, which allows our application to serve HTTPS traffic, so that we can get that green lock in the URL bar, this little guy up here, so that it looks really, official and secure and authoritative, whatever. People are going to trust our website, want to give us money, all that good stuff. So that's roughly what we're trying to achieve today. So unfortunately, a lot of these steps can kind of take a while, maybe take like an unspecified amount of time. So for example, like just buying a domain name, they say it can take up to 3 days to register the domain name. In my case, it took a little bit less than an hour, but that's still, too long for y'all to wait in a demo. So a lot of these steps I've set up the night before, and I'm just going to walk you through how I built this application. But I don't think we should be missing anything. Should be able to show you all of the steps. Okay, so next thing I want to show you is that before I even go to Amazon AWS, there are a couple of changes I'm going to make in my Python application to prepare it for deployment. So over here, I've got basically a copy of my news site application. So I took it out of my demos folder because that was one big Git repository. So now I have one folder that's just a single Git repository for just my news project that I'm going to deploy. Let's walk through this application and see a couple of changes that I had to make to the settings file. So first of all, setting debug equals false. So, before it was really convenient getting all those Django error messages right on the screen whenever anything went wrong, but it's very insecure. You don't want the user to see all that information. So we're going to set debug equals false. All right, so we just don't want to get the extra logging, not giving any clues to hackers or whatever. We need to set allowed hosts. In theory, this should just be, the domain name of your website. We can also just set it to star, saying that the clients can request our website no matter what the domain name is. So we could move the website to different URLs, or the user could request it by the IP address or by the default Amazon URL or by our custom domain, and all of those will work. If we don't want that, we could specify exactly what the host needs to be. Let me see if I can give you a clearer idea of what that actually does. Not supposed to have a host header on every HTTP request. Not seeing it for some reason. Okay, whatever, don't worry about it. Point is, Django needs to have a whitelist of, I'm trying to think how to put this. Like anytime a client sends a request to a server, they have to say what domain they think they're contacting. And so if you want to be more secure, you can put the actual domain name of your website. It prevents against certain specific attacks, but I'm not really concerned about that. So I'm just going to move on at this point. So set allowed hosts equals star for the name of your website. So another thing that we'll have to change. So this was a little bit tricky, but we need to add CSRF trusted origins. So apparently, I've told you before how when you add Django REST framework into Django, it kind of changes the security rules around CSRF and changes what you have to do in order to satisfy it. So it also turns out that when you deploy a Django application, when Django REST framework sees that it's running over HTTPS, which we're going to do at the end of our demo today, it employs even more like CSRF protections. So apparently you need to specify like a domain that doesn't have to like satisfy the CSRF requirements. So we're saying that on our own domain, we're not going to have CSRF checks, but these are going to be for like cross-domain requests from other websites. So that prevents us from getting hacked by, clicking on random links in our email or whatever. So this is kind of looking ahead a little bit, but this is the domain name that I registered for the demo today. We're going to build a regular size website. And so I've specified that as our CSRF trusted origin. So website requests coming from our own application are not going to have to deal with the CSRF requirement because we are trusting ourselves. And then last thing is we need to install gunicorn. So I mentioned that this is a server that we're going to use on our actual EC2 instance, but it's also a Python module. So we can install it locally to have it be ready for us when we deploy it on the server. So just like anything we install with pip, oops. So just like always, we're going to install it, and then we run pip freeze, and then add that to our requirements.txt file. All right, so that's all the setup I'm going to need to do for now. So now I'm going to go to Amazon. So I think it's aws.amazon.com is the initial URL. And you have to register. They have like a million captchas for you to do. But eventually, you get to your Amazon dashboard. And most importantly, at the top, there's this search bar where you can just type in whatever you want, and it'll try to find Amazon searches or Amazon services that match what you're looking for. So AWS can be kind of intimidating to use because they have just so many different services. So here, I just searched for EC. Tells me that 93 results came up. I'm gonna refine that. EC2, okay, they still have 9 different services that have EC2 in the name other than just the EC2 service. And then apparently there are 40 features that include that. So there's a lot of stuff going on Amazon. But thankfully, the thing that I'm looking for is the top result. I want to make a virtual server in the cloud. Excuse me.
Bless you.
Thank you.
Bless you.
So we're going to click on.
Bless you.
Thank you, everybody. Appreciate it. So we're clicking on EC2. So conveniently, you get this nice little dashboard here that tells you how much stuff you have running currently. Andrew, you have a question?
Yeah, so I've never used this. Do I have to go create like the AWS like free account right now? I'm looking at the Amazon website.
You do not. When you register for AWS initially, your account is automatically placed in the free tier for the first year that you're using it.
Okay, but I still have to create like the AWS account, right?
Yeah, you do have to register,
Okay.
but there isn't like a special free account that you have to make. It's just everything is free for the first year. All right, so here it shows me all of the resources I'm using currently. That's a pretty useful thing to keep your eye on because you have to pay for everything that is running while it's running. So, if you think you're only running one application, but this tells you that you've got like 11 running instances, then, maybe you've got some running apps that you forgot about, and you should shut those down to get your costs under control. Something that's important to note, though, is that all the services and, well, most of the services in AWS are split up by regions. So by default, I'm in US East 1. Now I can change that. This is the Zoom overlays driving me wild. So I can change that with this dropdown. I can create resources in different regions. They got a bunch in America and then a handful around the world. I'm going to stick with the default US East 1 for now, though. My point is just that this table is only showing me the resources I have running in North Virginia. So a problem I've seen come up in the past is, someone makes a resource in US East 2 in Ohio, and then they make something else in Virginia. So now they've got resources in different regions. They'll show up in different dashboards. And so it might be hard for them to know, why am I paying so much for these instances when I only see the one thing running here? So just be aware that there are different regions where things run in. So I was setting this up last night, so I have one running instance, but for all y'all's doing this for the first time, you're going to launch an instance. Click launch. You give a name for your app, just so you can identify it in the list of other instances you have. So let's see, they ask you to choose an operating system. So Amazon has their own version of Linux that they're trying to encourage people to use. Allegedly, it's fast and efficient, and it works really well on Amazon's hardware. I'm sure it's fine. I don't trust them. I would prefer to use Ubuntu just because it's what I have the most experience with, and this is what most tutorials on the internet are written for. So I would select Ubuntu 20.04 long-term support version as my operating system. And take note that this is free tier eligible. Not everything is compatible with the free tier. And so we're going to try to stick to the free tier as much as possible. And then we need to specify an instance type, which is really just how strong of a machine do you want. So, you can get a 16 core, 32 gigabyte memory machine, that's got a gigabit per second Ethernet connection. I don't know, but that's not what we're doing here. We're using the super small, tiny, cheap server. This is basically like a toaster that we're running on Amazon Web Services, but it's free, so that's great. So this is called the T2.micro is the name of this instance size. So micro indicating this is very small and underpowered compared to, the 2x large machine that they've got. So we're using micro. Now, the next thing we're going to need to do is create SSH keys that we can use for logging into our website. So has anyone used SSH before? Has anyone heard of this technology?
Yeah,
I use it. Or sorry, go ahead.
We've been using it for GitHub this whole time, or at least I have. But yeah.
Okay, yeah. GitHub does use SSH, but have we ourselves typed like SSH at the command line?
You can remotely access another computer through SSH and then their IP address.
Yeah, that's what we're about to do. So that's what SSH is for, given an IP address, which we're going to have when we launch this instance. We can use SSH to connect to it and get shell access, pretty much the same as what I'm doing here at the shell. Now, in theory, you can just use a password to log in via SSH, but that's not preferred. That's not the most secure way to do it. It's preferred that you create keys. So these keys come in pairs. There's a public key, which the server holds, and then there's a private key, which you hold on to. So because I already have a key pair here, I can just use the existing key pair. So if you want, you can have one set of keys that you use to log into all of your different applications. Or you can have different keys that belong to different people depending on what they should have access to. But for you all doing this the first time, you're going to create a new key pair. So what that's going to do is generate a file for you that you can then download. You just click a download button and then save it to your computer and make sure you don't lose it, because you cannot get a second copy of it. You'd have to just generate new keys, which is not the biggest problem, but it's a minor hassle. So let's see, I put my keys over in /code/keys. Demo.pem was what I named my key. .pem is a file extension for these kinds of SSH keys. So this is what an SSH key looks like. Starts with begin private RSA key, whole bunch of text in the middle, and then end RSA private key. So I'm going to keep this securely on my local machine. This does not get uploaded anywhere. But now I can use SSH, excuse me, in order to access the server. Well, actually, before I can SSH into the server, I need to know what the IP address is. So we're gonna have to do a couple other steps here. Because I'm not quite finished launching the instance. So let's see, other settings here, I'm just leaving at the defaults. That one is a key pair. Cool, so that was successful. That's all it takes. Okay, so here is the demo app that I just launched. It's pending right now. It takes a few minutes for it to actually be up and running and available. So I'm going to be using the demo app that I created yesterday instead, just to continue testing things out. So if we scroll to the side here in this table, we can see that we have a public IPv4 address. This is what we're going to be using to SSH into our server. So here's how we're going to do this. Use the command SSH. And then we have to specify the key that we're using. We have to say our identity. So that's -I. So this is my identity for this server. It's this key is identifying who I am. So I'm passing that in with the -I flag. And then I'm going to say who I want to log in as, and go as root, and then at IP address. So just type that in, see what happens. Okay, so this is the kind of thing you used to be able to do, but it's sort of considered a bad practice to log in as the root account for these like cloud servers. You're supposed to log in as an unprivileged user and then only use sudo to do root things as needed. And so they're even giving you a hint here. They're telling you that the default user is called Ubuntu. It's not root. So I'm just going to change this command here. SSH as Ubuntu, still at the same IP address. Okay, so now I have logged in. You can see that my prompt has changed. Now it says Ubuntu at, IP 172.1.8529, whatever. If I do ls, I'm not in Kansas anymore. I do pwd/home/Ubuntu. This is not my local machine anymore. I have SSH'd into a remote machine. I'm going to back out real quick, just because it's very likely that some of you will actually run into problems before you get to that stage. You might find that there are some problems with your SSH key. So, here. Okay. So when you do ls-l, that's the long output, shows you a little bit more information about your files and whatnot. This first column here shows the permissions for this file, saying who can do what to this file. So the way you read this is there's 9 different permissions, because there's really 3 different actions and then 3 different types of user, or 3 different people who might do that action. So let's so I guess if we just look at this folder here itself, it's easier to see because it has most of the permissions enabled. But the first 3 letters here are what the owner of this file can do, or the owner of this folder, because this is dot, this is referring to the current folder. The owner of this folder can read it, they can write it, and then they can execute this folder. The second 3 letters here are people in the group. So this folder belongs to the staff group. So maybe if you're not the owner of this folder, but you belong to the group that owns this folder, then you can read and execute this folder, but you cannot write it. So we have a dash instead of a W. And then the third set of permissions here, this is for all other users, for users who are not the owner of this folder and users who are not the group owner of this folder. Any other user is able to read and execute this folder, but they cannot write to it. So those are kind of default permissions for folders. But for our SSH key, we need to lock down the permissions more than that. When we try to log into the server, SSH is going to deny our request if the permissions are too permissive. And so we have to set it to look like this. This is saying that the owner of this file can read it and write it, but they cannot execute it, and no one else can do anything to this file. So the way that we set that, with sudo change modification, chmod, and there's little numerical codes for different sets of permissions. So 600 is what I'm doing here. This means read and write for the user, no permissions for the group, no permissions for everyone else. So this is what I ran previously. If I do this again, it should do nothing, honestly. It's just going to set the key to the same permissions it has currently. So you might need to do that in order to get SSH to respect your keys. Because by default, when you download the file from Amazon, it's going to have very open permissions. All right, so I'm logging back in. Now, when you log in initially, it takes you to your home folder. So /home/Ubuntu, it's just the folder with your name on it. Because like I was saying, we logged in as the user Ubuntu. So this is that folder with our name on it. Just like when I'm locally and I have /home/Rafael Sirota. Here we've got /home/Ubuntu. By default, there's nothing in this folder, but I have cloned the application down. So that's the next step that we're going to have to do, is we're going to go to GitHub. Geez, why is it so hard to get to my account? Okay, so we go to GitHub, you get the clone URL, and just like we would locally, we git clone and then the repo URL. So I already have it locally here, so I'm not going to run this command again, but that's all you do to get it from GitHub. And here's my news project, same one I had locally. So now I have to do some server specific setup. There are some new packages that I'm going to need. Some of these are things that I installed like during Install Fest months ago. And so I'm going to basically just repeat Install Fest on the server. And some of these are going to be specific to the server. These are things that I need in Linux that maybe I didn't need in Mac OS. So the first thing is sudo apt update. Apt is the package manager in Linux from which we're going to download all these other packages, but it might be out of date by default. I don't know why it's out of date on like a brand new instance that I just created, but it is, so we have to update it. We run sudo apt update. This shouldn't take more than a minute or two. There we go. Also, I did it yesterday, so it probably doesn't have to do a whole lot of work when I run it again today. So Python 3 is pre-installed on this machine, so you don't have to install Python itself. Pip is not pre-installed, so I had to install pip like so. Postgres was not installed, so I'm repeating install fest and installing Postgres. You need to create a user in Postgres because the default user, well, you need to create a user in Postgres that has the same name as the user account that's going to access the database. So we need to create a user named Ubuntu. So this is saying first, we want to change our user to be the Postgres user, because by default, they're the only user that has permissions to access the database. And then we're going to create user, making them a super user with the name of the currently logged in user. So that would be Ubuntu. So this command is going to create a user for our Postgres database named Ubuntu so that they can log into the database make queries and all that good stuff. Another library we need, and this is all in the curriculum, by the way, just these commands line by line, so you don't need to memorize this. We need libpqdev. I'm not 100% sure what this is for, but psychopg2 would not install until this was installed beforehand. And just Googling around on Stack Overflow, people were telling me that that's what you need to get psychopg2 working on Linux, on Ubuntu. I'm not sure why, but it seems to be kind of the consensus on the internet. So I installed it as well, and everything's working out all right. We will need to install -r requirements txt, because this is going to, install Django. This is going to install Django REST framework. And also importantly, this will install gunicorn onto our server. Marcus, question?
You're muted.
Muted.
Oh, I'm sorry. I was saying, do we need to .them since we're on a virtual machine?
Why would you use Event?
I don't know. That's how we've done all of our Django projects. So
That's a really good question. I kind of want to open this up to the class. What do we think? Should we use a virtual environment on our server?
No.
I feel like it doesn't matter at this point because like the work should be done like before already, right? Like it's not like we're going to be developing on this server.
Yeah, we're not going to be doing any development here. That's true.
Isn't it already a virtual environment?
It is kind of a virtual environment in some ways. This is not a real physical computer I logged into. It's a virtual computer. That's true.
So when we do the virtual environment, the only reason we do it is to separate, those installs from the rest of our projects and our development environment. So since this server is only going to be hosting the one project, I don't really see why you would need to do that.
Yeah, that's my opinion on the matter. Now, truth be told, in pretty much every tutorial I've seen, people are like, here's how you deploy this Python app to, whatever web server. People usually show creating a virtual environment, but I'm pretty sure they're just like, they don't know what they're doing and they're just like following the steps and it's just muscle memory for them at that point. As far as I can tell, the only purpose of the virtual environment is to separate your multiple projects, but this server exists only to run this one project. If there was ever a situation where we might get confused by different versions of Django, I would just delete this instance and create a new one fresh that has only one version of Django installed on it. So I don't really see any value in creating a virtual environment for my server. Everything seems to work fine without it. But I don't know, some people just like typing and running extra code. So if that's you, you can feel free to use a virtual environment, but I'm not going to be doing that today. All right. So since I haven't made any changes to the database recently, I'm not going to make migrations. The migrations already exist in my project. I just have to run migrate, so that those migration files can be applied to the Postgres database we just set up here.
Do you need to configure your settings for your database user or anything in your Django project once you move it over? Your settings.py file? Like I don't know if you have like a database user and all that jazz.
This year?
Yeah.
No, I've not configured it at all. So I suppose I could have configured this to add the database user. But if you don't specify the database user, by default, Django is going to try to connect with the username that is just the user account that you're logged in as. So like when I'm running locally, Django tries to connect with the user Rafael Sirota. So my local Postgres is installed with the user Rafael Sirota.
Okay.
I
I think because I'm on Windows, I've been using Windows, so it might be a little bit different for me. And then coming
might
over
be.
to the Linux environment. So maybe something to look out for Windows users.
Possibly.
Maybe just the
So,
way my Postgres is set up on my machine and how it operates.
okay.
But
Yeah, we might have to troubleshoot a little bit. I'm not exactly sure what the defaults are in Windows. But like previously when I showed you that I was creating a new user for Postgres that would have the name Ubuntu, the whole point of that was because that's the name that Django is going to use by default to connect to the database, because that's the logged in user. So instead of configuring Django to use a different user to log in as, I just created a new user on the server so that the Django defaults were correct. All right. So after setting up the database, got to migrate it. Like I said, I already did this yesterday. So there's no need to do that again. And it's harmless, just does nothing, tells you nothing needs to be done. So next thing I'll need to do is build the application. Honestly, it's probably already built, just like from when I committed it, because I think the build folder is not get ignored, but still a good habit. So I'm going to build it anyway here. So we need to get npm. We can get this from apt. So just sudo apt install npm. And we don't even actually need node itself because we're not running any JavaScript code. We're just going to use npm to install things and build the project. So after sudo apt install npm install. I was not expecting this to do so much work because definitely did this yesterday. Sometimes npm install just does a lot for some reason. Oh, it's like doing some kind of one-time fix-up. Sorry, I didn't mean to make y'all watch this. So then the next step I'll run after this is npm run build. So that's going to actually, compile all of my CSS and JavaScript, put it into the static folder so that we can serve it. Andrew, question?
Since you're done developing here, like you would run the build, but you wouldn't watch it, right?
Correct.
Okay. Thank you.
All right. So I've built the application. So now I'm ready to start configuring those other tools, Nginx, gunicorn. But first, I think we're due for a break. Let's see, what questions do we have? Just about what we've covered so far before we take a break.
The IP address is just from our network settings, correct? That we're getting from?
So in the EC2 dashboard, so I got my EC2 dashboard, got my list of instances. We get this neat little table here. And then scrolling over to the right, this is your public IP address. And then this is that public URL that you get. So this is what I was saying before. EC2, 442.04.2872.compute1, Amazon AWS.com. That's the default public URL that you get for your instance, but I don't think that looks very pretty. So that's why I'm gonna have us get a domain name today.
Okay, thanks.
What other questions do we have?
I got a question real quick. So if you did, like, since we're just like practicing right now and stuff like that, so if you didn't want to buy a domain, how would you go in and add the allowed hosts after you already put it up to the EC2 instance with the IP or the domain name that's assigned to it?
I'm sorry, are you talking about?
Like if you wanted to edit, I mean, I don't know, I guess, never mind, it's kind of irrelevant because you could just push the Django project to the EC2 instance after it's already started. So you could get the domain name. I'm sorry if I'm not making sense. But if you wanted to use the free domain name, could you just push the Django project up after the domain name gets assigned to it?
Yeah.
Okay.
I mean, at some point you need to like change everything so it matches whatever you've got online with your DNS settings.
So I have a question more about like if we're using environment or the like .env files and everything for our environments to lock away secret keys and everything.
Yep.
When we need to edit those after being uploaded, are we just going to go in and Vim edit those on the server via SSH, or is there a better pipeline for doing those setups?
I mean, as a Vim enthusiast, I would like to tell you that, yeah, just edit it on the server with Vim. But more commonly, you probably want to store that locally on your machine. And then, however you want to store that securely, that makes sense to you. You do that, edit it with whatever editor is comfortable for you. And then you can copy it up to the server using SCP. We've talked about that before. But so you guys know what CP is. That's just copy. So SCP is just CP over SSH, where it even has the same syntax, honestly. Let's see if we can get an example here. Yeah, another example of terrible documentation, and we put the examples at the bottom. Actually, there are no examples. That's just terrible. But so just like with regular CP, you can, CP like source.txt / target.txt. You can do the same thing with SCP, except that one of these locations would be an IP address. So this is how SCP works. You can just copy files from your local machine to the server using SSH. So you need to have the SSH key on your machine, the same way I did for the regular SSH command. But yeah, practically going forward, that's one way that you could update like secret keys and things that aren't supposed to be in GitHub. Sound good?
Yep, thank you.
What other questions do we have? All right, so why don't we take a decent break now? It's 9:55. Come back at 9:10, and we're going to start setting up Nginx. Yeah. Hello, folks. Welcome back. So we're going to resume deploying this application here. Next thing we need to do is install Nginx, the front-facing web server that's actually going to be listening on the public internet. Did anyone think of any questions over the break that they want to ask before we continue onwards?
I asked it in the questions channel, but whenever we're doing our installs, SQL format and Django admin, do we need to have those in the path for everything to work properly with the servers?
What was the first one you asked about?
SQL format.
I don't think I'm familiar with that.
It was just one of the installs for the requirements, but it's not in the path that's set by default for Ubuntu. So I'm just wondering if we need to set that before going forward.
I haven't set it, so I think it'll be fine. And then what was the other thing you asked about?
Django admin.
Oh, yeah, you shouldn't need Django admin at all. You know, as soon as you clone your project down, you're going to have the manage.py file. And so you can use that to, you know, do any Django-y things you need to do, like run migrations. Right, do we have any other questions? Or are we ready to see how Nginx works? All right. So I think this command is actually missing from the curriculum, so I should add that in. But to install Nginx, it's pretty simple, pretty similar to how we've been installing other packages so far. Sudo apt install Nginx. So it's just in our operating systems package manager, just like most of these other tools that we've been installing. But now when I install Nginx, it creates a couple files on our machine. It's going to create a config file for Nginx. And we're going to have to look at that and make some changes to it. So so the config file is at /etc/nginx. And we'll first look in sites available /default. So this is not the actual config file that gets read, but kind of like an example config file that you can look at just to know what the structure of the document is. It looks like this has some of my actual stuff in it. So I must have changed this at some point. But anyways, this is how we're going to define what our server does. So you don't need to know the syntax of this like specifically. I mostly just copy and pasted this from a guide, but I want to explain to you like what's going on here so you can at least kind of read over it and say like, oh yeah, that makes sense. So first thing here we're doing is listen 80 default server. This is saying that, by default, our server is running on port 80. So that's the default port for HTTP web traffic. So, it's important that we have that up front so that, any regular web requests we're handling with Nginx. But like I said, this is our front-facing web server that's listening on the public internet. So requests from port 80 need to be handled by Nginx. All these hashes, these are comments, so we can just ignore those. Server name, I don't think is actually super important. Really what matters here is location / and then proxy paths to this URL with this port. What this is saying is that when we receive requests to port 80, Nginx is going to pass those requests forward to the same machine, but port 9000. So we're kind of juggling these requests from port 80 to port 9000. So since this is at /, we're going to do this for any request that comes in potentially. Now, the second thing that we're doing, we're declaring another location for static files. If we get a request that comes in that starts with /static, then we're actually not going to pass this to Django at all. This is Nginx saying that it's going to serve these requests by sending files from this directory. And so I know, because this is how I set up my application with Create React App and everything, that my static files are going to be in, my home folder, deployment, news, project, build /static. So now we're actually not using Django's static file server at all, which is really a beautiful thing, to be honest. Because previously, like, our Django server would get bothered by lots of small requests, like for the JavaScript files, for CSS files, for images, for just lots of little static files. And really, we would rather that our Django server is able to focus on the things that it's good at, that is, running Python code, dealing with users in our Django application, our models and whatnot views. Django is really not specialized as a static file server. So this is really great, because this is saying that if someone sends a request for a static file, Nginx is able to send that file to the user, and then Django doesn't have to know about the request at all. It never even touches Python. So that's a good way to reduce the load on our server. But yeah, so long story short, these are the two important blocks that I wanted to point out to here. Location / is how the main application logic gets run. Most requests that are not for static files, we just pass straight through to port 9000. Requests that are for static files, we just send a file from the build /static folder. So that is my Nginx config file. That was the kind of the example one. The one you actually need to change is in etc nginx sites enabled /default. So this is my actual config file. It's had a few other modifications to it towards the bottom, which we're going to explore later on in this lecture. We're not going to worry about that for right now. But so I've created my basic Nginx config file that should at least allow HTTP traffic, but not HTTPS traffic. Now, if I want to double check my config file, because I'm not an expert on the Nginx syntax, I don't really know just from looking at it if it's correct. Thankfully, Nginx has a command built in that helps you deal with this problem. Type sudo, just clear my screen, sudo nginx -T. This is for test. Nginx is basically just going to read over your config file and tell you if the syntax is valid. So it generates a lot of output for some reason. Most of it is just copying your config file and just showing it to you again. But at the very top, config file syntax is okay, test is successful, so that's great. That makes me feel confident that I didn't forget a semicolon or something. Because literally, where is it? So literally, if I forgot a semicolon, at the end of this line or at the end of this line, my server would just do nothing and silently fail. I would have no idea why it wasn't working. So it's good to do that Nginx test command just to get some kind of validation that you didn't make an obvious mistake in the config file.
So is the config file on your computer or on the server base in AWS?
This is on the server. So you can tell by the prompt here, it says Ubuntu at IP. So this is not my local machine. I am on the server. So yeah, this config file never exists on my machine. So honestly, for this demo, in order to make a couple of changes to it and just for debugging and whatnot, I did just manually change the config file using Vim on the server. You all might not find that very comfortable. And so you would probably rather do what I mentioned before, where you copy it to your local machine, edit it locally, and then use SCP to copy it up to the server. So there's a few different options for how you manage these files. Just do what's comfortable for you. Okay, so that's how we configure Nginx. And now at this point, we should be able to connect to our server via HTTP. So we don't have SSL set up yet, but we should be able to connect via HTTP. Except that actually we can't. There is one other thing that we're going to have to do in the AWS console in order to actually connect to our website from the public internet. So firewalls are an interesting topic. In Linux, there is a built-in firewall. So I used to write firewall rules on a local instance using, there's a tool called IP tables. And there's a newer tool, Uncomplicated Firewall, that also lets you configure the firewall on the machine itself. But in AWS, they're a little bit more sophisticated, a little bit more organized than that. And the firewall is not actually configured on the machine itself. So if I just try to check the rules for the uncomplicated firewall, it would say that the firewall is disabled, that everything is allowed in and out. But if I look at the AWS console, I can see that there are some firewall rules enabled. Because this is kind of managed at a higher level in AWS. So let's go to the console, see if we can take a look at that. So I'm going to my first demo app here. And in this bottom section here, looking through security. Okay. So I clicked on the instance itself, went to the security tab. At the bottom, we can see inbound rules and outbound rules. These are just general rules about what kind of traffic can go in and out of this instance. So by default, let's close the inbound rules for a second. By default, for the outbound rules, it's just all ports, all protocols, any destination. So by default, there's no restrictions on the data you can send. Your instance can send requests anywhere on the internet. There's no firewall preventing that. But for the inbound rules, by default, you only have this top rule. So I added this bottom one last night as I was configuring this application. But by default, you only have this top rule for your security group, saying that users can only access via port 22 over the TCP protocol. So I mentioned earlier that HTTP traffic happens over port 80. So that's the port that we need to open up in order to enable web traffic. Does anyone know what port 22 is for? Has anyone heard that before?
SSH.
Do you know that, or are you guessing?
Sounds familiar.
I agree.
Okay, why do you think that?
Because I've seen it a lot of times.
How else would we be able to access it like we just did?
Exactly, I was
Yeah.
about to say that.
So I like John's answer. You just saw me connect to the server using SSH. So we've got to believe that that port is open. So SSH for connecting to remote servers, you can technically do that over any port that you want. Traditionally, that is done over port 22. If you don't specify a port, 22 is the default port for SSH. I'm gonna write that down just for funsies. So by default, the only way that you can connect to the instance, the only way it can receive any data is through SSH. So we can log into the server and install stuff or whatever, that's great, but we can't actually accept HTTP requests. So I'm going to edit the security group, click this little link over here. We got a couple tabs for inbound and outbound rules. I want to modify the inbound rules. Edit inbound rules. And so this bottom one here is the one that I added recently. So there's probably a few different ways that I could set this up that would do the job. This is more secure than just saying all traffic, but this is not as specific as it could be. Because really, I only need TCP ports 80 for regular HTTP traffic, and then port 443 for HTTPS traffic. But I just felt like making one rule instead of two. And I don't think there's any harm in opening the other ports, really. I mean, I guess it would be better if I didn't. But for this example, I've just created one rule that allows all TCP traffic on all ports. Alrighty. So that actually opens up our instance to web traffic. So after we do this, we should actually be able to send HTTP requests to it, get a response. But it's not going to have a pretty domain name. We want to look like we're professionals. We're going to purchase a domain name and then change our DNS settings so that users can type in the domain name to get to our website instead of just the IP address. So to do that, we're going to use another Amazon service. So in years past, this was a bit more of a hassle because one company would rent you a server and a different company would sell you a domain name, and then a different company would give you an SSL certificate, and just you had to merge all these different services together. It is very convenient, I would say, that AWS is able to provision the domain names for you and configure your DNS, and then also like configure your actual servers for you. You can do all this in the same organization without having to like transfer domains between companies. So please trust that this is just much less awkward than it used to be. And I really appreciate doing things all in AWS, having this kind of unified ecosystem where they make things as easy as possible for you.
Is that why there's a lot of certificates that, like, when you go into a site says a certificate is not valid or anything like that? I see a lot in certain sites. And they make it unsecure.
That could be about the SSL certificate. So I think that's looking a little bit further ahead in today's demo. But that's related, I guess. I mean, I have to generate a certificate in order to get this little lock in the corner here, and it's only valid for a certain amount of time. So if I fail to renew it, then all the visitors to my website are going to get super scary looking error messages saying that this website is probably trying to like hack your computer and steal your soul or whatever. So kind of related, but we'll touch on that more later in today's demo. All right. So in order to get a domain name for my application, we're going to use Route 53. It's another AWS service. So these are the only two services that we're going to use today, are EC2 and Route 53. So if you go to the little domains tab on the left, you can check your registered domains. They have a button here that lets you register a domain. And they have this nifty little search engine. That will tell you, if the domain that you want is available. So I could get nifty little searchengine.com. That's available for $12 a year. If it was not available, they'll show me some options using some like top level domain names. If you really want to be a hipster, you can use one of the like less common ones, but make it like form a word with the rest of the domain. But for search engine optimization, I would honestly recommend that you use a .com domain. Yeah, I would even stay away from .net or .org. Just use .com for like everything, honestly. I think it's fun, like how many different top level domains there are, like .ninja. Like who the heck is getting .ninja domains? But they're just like really bad for SEO, really bad for having a business. It just doesn't make your website look trustworthy. So like there's a business I used to work for, Uncorked. Their website was at uncorked.biz. And I really loved that. I thought that was super cool that they had a .biz domain because like nobody uses those. Certainly businesses very rarely use the .biz domain. But like in the time that I was working there, they ended up changing their website address to use a .com instead, just because it's so much more relatable. It's easier to say to someone over the phone. It just makes all your communication easier. So if you're trying to sell something to somebody, I would resist the temptation to use a .ninja domain and just use .com. But regardless of what you choose, they're pretty cheap, which is pretty great. I've seen a lot of registrars that will like price gouge you. So like a .ninja or some other like really popular domain name might cost you like 50 or $100 a year. Or there might be some like luxury domains that like for whatever reason have a really popular keyword in them. And so they'll be sold for like thousands of dollars. So you can potentially spend a lot of money on a domain name. In fact, some people make their living by just buying domain names that they expect to be popular and then like selling them in the future for tons and tons of money. But yeah, so I just really appreciate that these are all very reasonably priced. So I'm not going to buy another domain because I've already got one. I've got regular size website.com. So I'm going to click on that. Now, in order to get this domain name to connect to my URL, I'm going to have to create some DNS records. I'm going to click Manage DNS here. So these are organized into different hosted zones. So for every domain name you register, you can have a set of DNS records. So I have a set of DNS records just for this one website. So I'm going to click through here. So now these bottom two were created by default. So I'm not going to worry about those. I'm not going to talk about those. But this top one here, I had to create. So we're going to talk about that in just a second. But first, I just want to pull the class. Does anyone have any familiarity with DNS? Has anyone used this before? Can anyone like even define the acronym?
I can't define anything, but I've used it.
Okay.
Domain name service.
It's, I think the S is system. Yeah, pretty close. Domain name, S. So yeah, it's a system, it's a service for domain names. Does anyone know anything more about it?
I'm pretty sure it's like a phone book where the name actually redirects you to a specific IP address or multiple IP address, depending on what you have in your DNS settings.
I don't think we're going to get a more concise explanation than that. So I'm going to say DNS, it's like a phone book. The purpose of DNS is to convert domain names into IP addresses. So it's a very common question that you get asked as a junior developer in interviews. It's like, oh, when I type google.com into my URL bar, what happens? Explain this in as much detail as you can. And it's definitely possible to explain that in more detail than the interviewer is prepared to handle if you're willing to talk about DNS. So like in order to reach google.com, we need to know the IP address for google.com. My browser doesn't know that automatically. So when I type in google.com, what my browser does know is the location of these DNS servers. So DNS is a network of servers that can translate domain names into IP addresses. So note that it's not just one database that has a list of all the domain names and IP addresses on the internet, but it is a network of servers. And if you want to understand how those servers relate to each other, you got to read the URL, but you have to read it from right to left. So let's take a look at a URL really quick. Is that even valid? No, it's not. So that is valid. I don't want you to look at my email. Okay, so we're not going to actually go here, but let's look at this URL, mail.google.com. So when I hit enter, and there's the question of like, how does my browser know where this server is? So what my browser knows automatically, just to begin with, because this is like built into the browser, this is built into every modern browser, is my browser knows the location of the .com DNS server. This .com DNS server should know the location of any domain inside of it. So I'm going to reach out to the .com DNS server and be like, hey, do you know where I can find mail.google.com? And they're going to tell me like, hey, I don't know anything about this mail stuff you're asking about, but google.com, like they're over on this other server over here. Why don't you try asking them about that? So then I send the same request to this other server, and they'll say like, oh, mail.google.com, like, yeah, that's a subdomain within this domain. Their IP address is over here. And then I can send a request to that IP address. And note that you can have as many subdomains inside of a subdomain as you want. If you own google.com, you can create mail.google.com, sub.mail.google.com. You can create as many subdomains as you want inside of your domain if you own it. But the point is that there's like a series of servers that have to route you from one to the next, getting more and more specific before finally you find the one server that actually knows, where mail.google.com actually lives, and they're not just redirecting you to a different DNS server. So I think a lot of interviewers, when they ask you that question, they're just expecting you to say that like your browser looks up the domain name in DNS and then converts that domain name into an IP address. I think most interviewers don't actually understand how the DNS lookup is a multi-step process. And I mostly just think it's cool because it helps me understand the URL structure a little bit better, but it's not really essential knowledge. All right, so like I was saying, in order to map this domain name onto an IP address, we're going to create DNS records. They're like records in a database. Click this create record button. And this is great. This is going to be actually pretty simple because we leave most of these settings at their default values. So there's only one thing. Well, so let's back up a little bit. So record name, you might be wondering what to put here. You don't need to put anything here, honestly. This is for subdomains. I think name is kind of a weird name for it because it sounds more important than it is. But this is for like, if I wanted to have, the example here is blog.regularsizewebsite.com, I can create that URL. If I wanted, www.regularsizewebsite.com, I can create that URL. Because this is a subdomain, just to be clear. www is a subdomain, just like mail.google.com is a subdomain of google.com. So if I just want to create a record for the raw base URL, I'm going to leave this blank. Then there's the record type. So the most basic type of record is an A record. It's the first letter in the alphabet. Why not? And this does what I was talking about before. It maps an IP address. Well, the description isn't quite how I would say it, but it maps a domain name to an IP address. So it maps this domain name to whatever IP address I type in here. So for the value, this is the only thing you actually need to type in when you're creating an A record, is the value. So I just go to my EC2 dashboard and I get the IP address of my instance. I paste that right in there. And then that creates a DNS record. Allegedly, it takes like 24 hours for the DNS to update, which is another reason why I did this last night. Although practically speaking, I've seen the update happen in like 5 minutes. So your mileage may vary. I don't know. There's a few other records that you can create that also change, how names get looked up. I guess MX is used for setting up a mail server. I've done that once, I think. But what's also nice to know about is Cname Records. Excuse me. So an A record maps a domain name to an IP address. For example, sizewebsite.com maps to, I don't know, whatever the IP address was. So the other record that I use sometimes is a Cname record. This maps a domain name to another domain name. For example, www.regular-sized-website.com maps to regular-sized-website.com. So this is useful if you have like a bunch of different URLs that should all get you to the same website. So imagine for like google.com, I can type in google.com, google.com, goggle.com, like www.google.com. There are a variety of different ways you can spell Google. You can use the subdomain or not, and they'll all redirect you to google.com. That's the canonical name of the website, which I'm pretty sure that's what the C stands for. Yeah, it's the canonical name. So it's the like actual real name of the website, saying that like our server will listen for requests that are either www or without the www. But we're saying that without the www, this is a canonical name. This is like the real name for our website. Andrew, question?
Yeah, if I type in the IP address into my browser search bar, will it re-show the domain name?
No. Because if you just type the IP address, then the DNS doesn't get used at all.
But it'll still connect to the website, right?
Right. So this kind of thing is useful if you find yourself moving your application around to different websites. So imagine if you have like 6 different URLs that should all take you to the same application. Well, if you move your website to a different IP address, you might have to update all those different records if you had 6 different A records. However, what's smarter is you just have one A record pointing to the IP address, and then you have a whole bunch of Cname records that point to the domain name for the A record. So that way, when you move your website from one IP address to another, you only have to update the one A record, and you don't have to update the Cname records. But I have not set up the www domain. I've created just this one A record. So I should be able to go to my URL, regular-sized-website.com, and it'll take me to what's being served from that IP address. All right, now there's one more thing I forgot to mention before we take a break, and that is about gunicorn. So I showed you that we installed it, but now we need to run it. So I already set up Nginx, so it's listening on port 80 and then sending requests to port 9000, but nothing is listening on port 9000. So those requests get passed through and then just dropped. So actually, I'm just going to go to my website here. It's not expecting that to load. Hang on a second. Okay, so gunicorn was running in the background, which is why my website is actually up. I'm going to kill that real quick. Okay, so now this is what our website looks like when Nginx is running, but gunicorn is not. So this error message has nothing to do with Python, has nothing to do with Django. This is just the generic Nginx error message that it received a request and then it wasn't able to successfully pass it through. So what we need to do now is use gunicorn, or I saw some really great alternate pronunciations in the chat. My favorite is guncorn. You can say it however you want, and I'm not going to tell you you're wrong. We need to type gunicorn Now this is going to look a little strange. News project.wsgi --bind 0.0.0.0:9,000. So we're invoking gunicorn, saying what app we want to run, running the news project WSGI app. And then we want to bind that to port 9,000. So this is how we get gunicorn, this is how we get Django to listen on port 9,000 for those requests that Nginx is passing forward. So I think that this syntax here looks a little strange, the news project.wsgi, because this is not an actual file that exists. You know, we've got the news project folder, and then inside of news project, there's wsgi.py. So this is not actually like a file name, but it's kind of like a Python module. So like news project is a Python module, WSGI is like a class inside of it or something. Don't think too hard about it, but this is the syntax. Gunicorn news project.wsgi --bind 0.0.0.0:9,000. Oh, bind is one word. So now I refresh the page, and now my regular size website is online. So, you know, in this demo, SSH or SSL has already been set up, but I haven't showed you that yet. So that's the next thing we have to talk about. So I think we're about due for a break again. Does anyone have any questions about what we've seen so far before we take a quick break? Andrew.
Can you just say what you just did? You just made it so that your Django server can listen to like the request through gunicorn?
Right. So before I ran this command, Nginx was listening on port 80, and then it would forward those requests to port 9,000, but there's nothing listening on port 9,000. So that's why we were getting that 502 gateway error, which, what is 502? Okay, so the server was acting as a proxy and received an invalid response from the upstream server. So Nginx is trying to be a proxy to gunicorn and didn't get the response it expected from gunicorn. Sorry, what was your original question?
That was it. You explained it. I just
Okay.
wanted you to just re go over it.
Cool. Any other questions I can answer before we take a quick break?
Yeah, Raphael, do you mind just like in like a brief statement, just like go through the list of things you just did? Like from the top.
Like everything I've done today?
Yeah, like started the virtual machine and everything. Just like not like all the nitty gritty, but just like in a broad statement.
So, I mean, first of all, there were a couple small changes I made to settings.py to prepare it for deployment. You know, setting debug equals false. We committed in GitHub, pushed it up so we can then pull it down onto the server. We installed various dependencies. Well, so let's see, we pushed up in GitHub. We created the EC2 instance in AWS. So that's clicking through the EC2 dashboard in their console. Then once we get the SSH keys for our instance, we're able to log into it with SSH. Once we've logged in, we can clone the project down onto our instance, and then we can install the software that it needs to run. So such as pip, Postgres. We run the migrations on our new Postgres database after doing the database setup. We install NPM so that we can install our NPM modules and then build our application. we set up Nginx to receive requests from port 80 from the public internet and forward them to port 9000. And then now we're setting up gunicorn to listen to requests on port 9000 and forward them to our Django application.
Thank you.
And I guess also in between there, we bought a domain name and configured that to point to our IP address. What other questions do we have? And if you're, as long as we're talking about domain names, .io, at least a few years ago, used to be very trendy. That's why they're like super expensive. Technically, the domain is from the Indian Ocean. So whatever tiny island nation is over there is making a ton of money off of all of us hipsters buying domain names. But yeah, they're really expensive just because developers want them for some reason, just supply and demand. But yeah, if you want to show people that you're serious about having a portfolio, or if you're just a hipster, then .io domains are pretty cool. All right, so do we have any more questions before we take a break right now? Going once, going twice. All right, welcome back, class. So the last thing that we've got to talk about today for setting up our news site for public deployment is HTTPS. So there's a few related terms here. Ssl, TLS, and HTTPS. Can anyone tell me what the difference between these words is? Does anybody know offhand?
The difference between what?
SSL, TLS, and HTTPS.
Say a few different letters. Say they have different letters.
That's absolutely correct, 100%. What else? All right. So if you don't have much existing familiarity with these terms, that's great, because anything that you would have heard before is probably misleading. So let me tell you what's up. So way back when, I want to say it was like in the 90s or something, people invented SSL, which is Secure Socket Layer. This is a technology for having encrypted communication between a client and a server. So that way, people who are, for example, sitting in a coffee shop while you're doing your banking or whatever, they're not able to snoop on your traffic and see the passwords that you're sending to various different sites. So see if we can get some Wikipedia. Okay. So there's a lot of confusion about the difference between these two terms, SSL and TLS. So, SSL, this is a technology from like the 90s, literally, for creating secure communications between a client and a server so that eavesdroppers cannot snoop on your traffic. In 1999, there was a proposal for TLS, which is basically just the next version of SSL. It was kind of renamed for marketing reasons, because it was developed by Netscape and they wanted to like put their brand on it. So they're like, no, this isn't SSL, this is TLS. This is a totally new thing that we have invented, but it was really just like the next version of SSL. So my point is that so in the modern web, SSL is not used anywhere. Instead, what we actually use is TLS, which is transport layer security. These are really just different words that mean the same thing. So again, just to reiterate that this technology got renamed and rebranded for kind of corporate marketing reasons, but it's really the same technology. So today, most websites use TLS version 1.2. They're saying that there's, what's this? I guess TLS 1.3 is the latest version. I'm not sure if that's actually in common use today. I've seen TLS 1.2 being used pretty commonly. It doesn't really matter because it's not something you have to worry about specifically. My point is that out of force of habit, many people will use the term SSL, even though this is not used anymore. So for example, there isn't really such a thing as SSL certificates. I'm going to create a TLS certificate. So no one is really using SSL on the internet anymore. It has been succeeded by this other technology, TLS, which is basically the same thing with a different name. A lot of people just refuse to use the new terminology. And so you'll often hear the phrase SSL certificate, just because it's really easy to say and it sounds cooler than TLS certificate, which is a slight tongue twister. In theory, these are synonymous concepts, or at least if you hear someone using them interchangeably, you can assume they mean the same thing. So don't worry too much about the difference between them, because people are probably just using those words imprecisely. But so this is just a technology for securing any kind of web request, any TCP request. So we can use these SSL certificates to secure different types of requests, different types of traffic. But specifically, when we use TLS to secure our HTTP traffic, we call that HTTPS. The S just stands for secure. So what this does for you is it doesn't, make your website perfectly secure automatically, because there's no like silver bullet to application security. But what this does is it gives the client a guarantee that the server that they're talking to is who they think it is, that you are authentic and that they haven't had the request intercepted by some other server. Because it's possible, like, if I live close to the user and I hack their router or something, that maybe they're sending a request that they think is going to regular-sized-website.com, but it's actually going to my hacker website, and I'm intercepting the request and modifying it before I pass it through. So you could be like interacting with a fake website that says it is actually this other website. But with SSL, that's a lot harder to fake. You have this really strong guarantee that, you know, if you're sending a request to google.com, that it is actually the Google corporation that is receiving that request and responding to you, and not just some hacker that is temporarily pretending to be Google. So it prevents these man-in-the-middle attacks. Or MITM. It also prevents other people from snooping on your traffic that are like locally. So like I was saying, if someone's in a coffee shop and they're just doing some online banking and you are next to them in that coffee shop, there are tools that you can download to your machine that let you just view the web traffic for everyone else in your network. So I used to play around a little bit with Wireshark. This is kind of the industry standard tool for doing this. I'm not going to show you how to use it today. It's not really relevant to the program. But the point is that Wireshark is a tool that lets you listen for HTTP requests on your network. So this isn't really something that I can do today, because in 2022, literally every website on the internet, with very few exceptions, is using HTTPS. So there's no unsecured traffic left to snoop on. But you know, maybe like 5-6 years ago, like I would get bored on a Sunday morning, hang out in a coffee shop, just see what I could see. And even at that time, most of the traffic was encrypted, most of it was HTTPS. But you know, I would notice some people going to websites over HTTP, and it's just kind of shocking that like I can see the contents of the forms that they're submitting, and I can see the URLs that they're trying to connect to. So if you want to prevent, you know, hackers like me from doing dumb stuff like that, you should be running your website over HTTPS so that other users on the same network aren't able to inspect your traffic. Okay. So like I was saying, HTTPS is not a silver bullet. It doesn't prevent all the security problems that can happen, but it does prevent these a few specific attacks from happening. So, you know, I like to say that there's no such thing as general security for an application. You can't just say an application is more or less secure than another, but there are specific attacks that you're able to defend against. So if you're using HTTPS for your website, these are some specific vulnerabilities that your website can defend against more easily. All right. So as far as how we actually get the certificate and how we install it, I hope that everyone is pleased with this part of the lecture, because this is going to be one of the easier parts so far, and certainly much easier than it has been in the past. So in modern times, there's this organization, the Electronic Frontier Foundation. Maybe you've heard of this. They're kind of like the ACLU of the internet. They're just really big into like free speech and whatnot, but in like a technology kind of way. And so their opinion is that every website should use HTTPS, that it's just secure and it makes the web better for everyone involved. And they want to make it as easy as possible to use HTTPS on your website. So this has been like over a decade now. I think that this tool has existed and they've been improving it constantly for just generating free SSL certificates for your website. Let's find where the actual docs are at for how to use it. Okay, so the actual tool that Let's Encrypt provides is called Certbot. It's just a robot that generates SSL certificates for you. So I'll click through here. We're at certbot.eff.org. And like, I swear, this is probably the nicest piece of technology I've used in my career. I can't imagine like a better experience for trying to get an SSL certificate. So I'm going to tell it first what server I'm using. I'm using Nginx on Ubuntu 20. And then it loads up these instructions for me. So it's going to assume that I know like nothing. So it's going to tell me, you know, first of all, like make sure you know how to use the command line. Make sure that the website is already running on port 80. Like I did that. I set up Nginx. Make sure you can access it with SSH. You can use sudo. Like great, we can do all those things. I've done that already. We need to SSH into the server. I already showed you how to do that. We need to install snapd. So this is actually pre-installed on Ubuntu. So again, we do not have to do this. This is honestly slightly contentious. This is another package manager. So on Ubuntu, there's already apt as the package manager. Ubuntu has added this new package manager called snapd. Some people don't like it and they're like, there's already a package manager. Why do I need a new one? Some people appreciate some of the new features that snapd has. It's supposed to be more modern and convenient. I don't really know what the difference is, but this is how Certbot wants you to install your certificate. And it's already installed, so why not use it? They want us to ensure that your version of snapd is up to date. It already is up to date. I didn't run these commands and it worked just fine for me. If you've been running Certbot previously, you need to delete anything you've done before. I have not done this before, so again, I'm going to skip this step. So then we need to install Certbot. So we're going to use Snap, which was that package manager that I said was installed by default in Ubuntu, in addition to apt. So we install Certbot. And then there's just a quick, simple command, just linking the Certbot where it was installed and then adding it to a folder that's on your path. That's just so that you can type Certbot at the command line like this, and then it runs the command. Because by default, it installs to a location where you can't access it from the command line. So we're just making an alias into a location that we can't access. And then this is the last command we're going to run with Certbot, sudo certbot -- nginx. So this tool is pretty smart. It understands what we're trying to do and it knows how our server is set up. So we just tell it that we're using Nginx and we want to get a certificate for it. And it's going to automatically generate the SSL certificate. And it puts it in a specific location on our machine. It tells us where it goes, but we probably don't need to look at it too much. And then it automatically updates the Nginx config file to use that SSL certificate. So this is really beautiful. This is like one of my favorite things about this tool is how it can like install the certificate for you automatically. Because traditionally that can be kind of a hassle. You know, if you don't know exactly where to put the certificate and how to declare it in your Nginx config, you might get error messages that you don't know how to debug. So Certbot just does that all for you automatically. You just run this command and you get like an interactive prompt. It's going to tell you, you know, what's your email address, so you can get like emails in case there's a problem with your domain. Most importantly, they ask you for the domain name itself so that it knows what domain it's creating a certificate for. And then if the checks pass, it creates a certificate and updates your config file. So let's just take a look at that real quick. So the top bit I showed you before, that was what I created by hand. So then there's some commented out sections that were already there by default. So this was here by default. I have not touched it. But this section down here, this was created automatically by Certbot when I installed my certificate. So note, it looks pretty similar to what I have up above, saying that we're passing all of our requests to port 9000, except that we're serving static files from this folder, build/static. But now we've got all these extra lines here that say managed by Certbot. So now it's listening on port 443 for SSL traffic. Now I mentioned before that while port 80 is the default for HTTP traffic, port 443 is the default for HTTPS traffic. So this is how we're preparing to receive those requests. This is where it's declaring the public and private key for our certificate. So like the SSL certificate, this is like a public key, and this is where it's put on our computer. We can look at it if we want to, but since Certbot is managing this for us automatically, we don't actually have to look at it or move it around. And then similarly, the private key for our SSL certificate is in this file. And again, they both have the .pem file name suffix, because that's what these kinds of keys look like. Apparently, it's also including some SSL configuration, which I haven't even read this file or this file, but Certbot creates them automatically. It includes them automatically. It seems like they're working as advertised. So I'm not going to ask too many questions. I'm just happy that it's working. I believe that this is saying that if we get a request to the HTTP version of our website, that it should redirect to the HTTPS version of our website, which is kind of important. There are some security vulnerabilities that you can have in your website if you have both versions available, both HTTP and HTTPS. Generally speaking, if you have an HTTPS version of your website available, you want all of your users to using it. You want all of your users to be using it, unless there's like some very specific reason why they can't and you need them to. So that's cool. You'll see in a second that if I try to go to the HTTP version, it's going to automatically redirect to the HTTPS version. So it's listening on both ports just so it can make the redirect, but it's not going to actually serve the full application over port 80. So here I binded gunicorn again to port 9000. Here's my regular size website. Yeah, so by default, Chrome doesn't want to show you if it's HTTP or HTTPS. If we click into the URL though, it shows us here, HTTPS. I can try to delete that S, go to the HTTP version. Actually, let's open the network tab, see what that shows us as I'm doing this. Go to the HTTP version. We see a request for regular-sized-website.com, gives me a 301 status code. That's a redirect. Oops. Come on. It's a redirect. And the location for the redirect is the HTTPS version of the same website. So I didn't do that in Django. I could have done it in Django, but Fortunately, Nginx handles that for me, making sure that all users are visiting the HTTPS version of my website. And before I forget, I want to add that there are a couple of other benefits to using HTTPS. So there are a lot of powerful features in your browser. That's what they're called. I didn't make up the term. Powerful features that are only available over HTTPS. So common examples include like geolocation, microphone, and camera access. If you're like me, you care very much about MIDI access, which is also a powerful feature. So you need to be over HTTPS to do that. Oh, also, if you want to access the accelerometer, you need to be over HTTPS. So I don't know if people know that, like, you know, your phone, for one thing, has an accelerometer in it that tells you how fast the phone is accelerating. So like if you want to throw your phone or whatever, you can write code that tells you like when it's at the top of its arc and when you catch it, dumb stuff like that. MacBooks also have accelerometers built into them, which I think is kind of funny. It's not actually for like dynamic real-time applications or whatever. The purpose of the accelerometer in your Mac is so that it can automatically detect if it's in free fall. So if you drop your Mac, it's supposed to shut off automatically before it actually hits the ground. And it does that by using its accelerometer. But apparently the accelerometer is also accessible in Google Chrome. So like using my MacBook right now, I could develop a website that tells me like how much my laptop is tilted one way or another. But that website would only work over HTTPS in case somebody wants to do that. So yeah, you might have some problems where you're trying to build like a really cool application with this like really cutting edge browser technology, but it's not going to work until you get HTTPS set up just for arbitrary security reasons. But yeah, so now I've got a website. The database should be hooked up and everything. We can create an account, Bill Gates. So it's going to be Bill. Sign up. Got to manually log in because I didn't make that one action. Even better. Log in. All right. Redirects me back to the home page. We've got these preferences and that logout button. See if I can set some preferences. Set our color theme to dark. And I submit this. Submitted it. The way my application is built, though, is that the color theme doesn't get checked until the page loads. So I'm going to reload the page here. Go to the show. And oh my gosh, look at that dark theme. Everything is just inverted colors now. So I can read this page at night. Maybe I changed my mind about that. Change that back to light theme. Refresh the page. Got light colors back on. So here I've got a full stack application, React and Django, running at https://regular-size-website.com. Still got the client-side routing though after the hash, but that's cool. This does not go up to AWS EC2. This is just, you know, spinning around my browser. I'm able to change these preferences. So evidently the database was set up correctly. I'm able to store this user and authenticate. Looks like I can log in, log out. You know, I click that log out button and it gets rid of the preferences and the log out button because I'm no longer authenticated. So yeah, that's a full stack deployment with Django React, Nginx, gunicorn, the whole shebang. I know you have questions. What questions do we have?
Question I have isn't necessarily about the SSL or anything, but
That's
when you
fine.
were doing your setup like last night or whatever, did you upgrade your version of Node? Because I couldn't get the run build work without doing that.
No. Should be the same version of Node.
It came with version 10, but I got warnings that it had to have like version 16 to do npx create and everything. And when I tried it with what I had brought over from Git, it failed on the builds.
No, I didn't have any issues like that. We can maybe debug it offline, or I guess if you want to share your code.
Well, I mean, I fixed it by upgrading Node. I'm just wondering if that was one of
right.
the steps that you did.
That was not one of the steps that I did. Maybe I just started with a newer version of Node than you. Not really sure. Sorry. What other questions do we have?
Raphael, if you wanted to deploy multiple apps under like different sub URLs, is that possible through Nginx and EC2?
So to be clear, when you say multiple apps, you're not talking about Django apps. Like,
No, I'm talking about full stack apps. Like, let's say you had a sub URL like app 1, and then that would bring you to this full stack application you have, and then let's say you change that to app 2, and it would bring you to a whole different full stack application.
yes, you can do that. Let's look at the DNS settings here for a second. So I could have multiple A records that route different domain names to the same IP address. So that might seem like a problem. Like, how does Django know what's what then if multiple domain names are going to the same IP address? But the thing is that Django is not going to just blindly handle every request that comes into it the same, assuming that they're all looking for the same server, but there's a few other checks that go on. So when you send a request to a web server, you're supposed to include a host header that has the domain name of like the website you're trying to access. Still not sure why I can't find this. Okay, here. So in the request to xkcd, I'm seeing this. I don't know why this isn't in every request. I could have sworn this was a required header. But in the request header to xkcd.com, there's this header host saying xkcd.com. So you might think that this is redundant. Like, I'm typing in the domain name and then the DNS converts that to an IP address. Isn't that sufficient? After I have the IP address, like, doesn't that tell me who I'm trying to contact? But like I was just saying, you can have multiple websites that live at the same IP address. And the way that our server distinguishes those is with the host header. So it's kind of like if you're sending a letter to someone's house, the address might not be sufficient to get that letter to the right person if multiple people live in the same house. So you might, put the recipient's name on the letter because you expect that the person who actually like takes in the mail for that household is not the person you're trying to send the mail to. So they're going to take in the mail and see like, oh, this one letter is addressed to someone else who lives here, but they're not me. I'm going to give it to them. So this is kind of a similar situation. You can have multiple requests go to the same IP address, but with different host headers, which indicates that they're intended for different applications.
So then would you also, in the Nginx config file, make the location sections for each different sub URL that you're trying to handle?
That's correct. I am not enough of an expert on Nginx to know exactly what that should look like. But I'm pretty sure that's the correct way to do this. And I think we could also manage it in Django, perhaps, possibly, but for sure, the correct way to do this is in Nginx. So like here, we have to say, this is the name of the server. So Nginx can know that if we get a request at this IP address, but this is not the host, then there must have been a mistake made. That's also why in Django, in our settings, where is this at? Project settings up high. That was already open. In the allowed hosts, this is what that's referring to. This is saying like, what are possible values for the host header that we should allow? So this is kind of the insecure version. I just said anyone can send a request, which is honestly how most web servers work anyway. I suppose the slightly more secure option would be to specify the name of my domain and say the only allowed host is regular size website or regularsizewebsite.com. Because apparently there are some very obscure types of attacks where if I was on my server, if I was reading the host header and then just like putting that variable into some other code that I executed, apparently people might try to spoof the host, just type in some fake data, put in code there and get me to execute their code on my site, which is not something I've ever heard of actually happening practically, but apparently that's why this setting exists, is to prevent those types of security vulnerabilities. So sometimes I feel like Django is a little bit overly cautious, a little bit paranoid. It forces you to deal with certain security problems that are probably not going to be an issue that like most server frameworks don't make you deal with, but it's not such a big deal, I don't think. Does that answer your question?
Yeah, I guess I'll just have to like kind of snoop around and learn more about like the Nginx config file and how to actually do it. But yeah, I'd answer my question that it's possible.
Yeah, so sorry to have a direct answer, but I think if you Google your question for Nginx specifically, you will find what you're looking for. What other questions do we have? Anybody? I know people are confused about this. There is definitely a lot of stuff that we saw today that you've not seen before. I'm sure you'll have to just.
The questions will probably come whenever we're going through it and then we get hit at snag.
Yeah, I was just going to say, I'm sure as you're working through it, you'll discover more questions and maybe at this point you don't know what to ask. So maybe at this point I might end the lecture a little bit early, release you to work on exercises. At this point, we do have a new exercise for you today, but also if you have not finished your React news site application, try to get that up to speed, integrate that as a single full stack application in one Git repository. Do your best to follow what I did today. Just repeat this demo. You can check out the video or look at my notes, check out the curriculum, try to get your full stack application deployed onto AWS. Because if you can, that's really cool. It looks very professional. I think it makes you look like you know what you're doing. And people will be happy to interview you if you have this professional looking website. So yeah, if there are no more questions.
Do we need to buy a domain name in order to do this to our new site?
So I think that this should work with just, where is it? Going up to EC2. EC2 dashboard. Oh my gosh, come on. Okay, it should work with just this public URL. You know, EC2 44204, blah, 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 compute one, Amazon, AWS.com. Proceed. Oh, doesn't like that. So it's telling me it was insecure because I got the SSL certificate for regular-sized-website.com. I did not get an SSL certificate for this URL. So I believe if you got an SSL certificate for the default URL that Amazon provides you, you could do the same setup. I haven't tried it, but that should work. But like seriously, it costs like $12 to get a URL. And I really think it makes a difference in how your personal projects will be perceived by interviewers or whoever. Like I think I might have mentioned before, but if you have some software project that you're really proud of and you're interviewing somewhere and you show it off to the interviewer, there's a good chance that, A, they're not going to look at it at all. But certainly if they look at it, they're probably not going to read your actual code. They're going to spend as little time as possible judging your application. And so you've got to think about like, what's their first impression going to be? You know, they're going to type in a URL to their browser and like, A, does the page load? Does the page load fast? Do you have CSS so the page is not offensive to their eyes? And also, do you have a real URL that looks like an actual website and it's not like herokuapp.com or .githubpages.io? You know, it's like a real custom domain and they have the green lock in the corner. So they're not going to, well, I guess it's not green anymore, but they get the lock in the corner and they're not going to get like security warnings saying that your website is trying to hack them. Like all that is in just a 5-second first impression after they load your website. And that might be all the time they spend judging your website. So you hope it's a good impression. Marcus?
Yeah, this is kind of not super related to this stuff, but is there like a way to link all your projects to just one URL? That way you don't have to purchase a lot. Like say I have a URL for my portfolio site and rather than buying a separate domain name for each project, could I just link them all under my one domain?
I would probably make subdomains for that. So where are we here? So I'm going to create a record. So let's say I make this here an entirely different app, .regular-sized-website.com. And the IP address, this would just be a different server entirely. So I can do that. I'm using the domain name I've already purchased. And then I can just make as many subdomains under it as I want to. Because if you own the domain, you can create as many subdomains under it as you want for free. And then I'll just set the IP address to be some other EC2 instance. So as long as they all have different subdomains, I can use the same domain name as many times as I want and have a whole bunch of different applications under it. And I guess there's also the option of just using Django apps, like literally build every different project you want as a different Django app and then put them all in the same project. And that's another option, I suppose. Does that sound good?
Yeah, thank you. That did answer my question really well.
Cool. Any more last minute questions? All right. So at this point, I'm going to release you all to take your lunch. When you come back, there will be pair programming. And Slack out your pairs over the next hour and a half or so. So we've got some exercises for tonight. Try to get caught up on all the React Django stuff, deploy your app. And other than that, I'll catch you all tonight at 5 p.m. for stand down. Thanks, everybody.